Hey everyone, Jerry here. Before we dive in, just a quick note for clarity. Everything you're about to hear is for educational and informational purposes only. This project isn't about promoting use, selling, or growing cannabis where it's not legal. It's about understanding the science, the history, and the relationship humanity's had with this plant since the beginning. We're exploring the truth behind it. Not opinions, not hype, just the facts and the stories that shaped them. Whether you're here for the biology, the cultural history, or the modern science, this series is built on research, not rhetoric. So take this for what it is, a lesson in how something ancient became part of everything we are. Before language was ever carved into stone, before the first hands learned to harness fire, the lineage that would become cannabis was already shaping its own code of endurance. The earliest fossil evidence traces this plant's ancestry to the late Oligocene epoch, roughly 27 million years ago, when a common ancestor of the Cannabiceae family split into two evolutionary lines, one that adapted toward the shaded understories of forest edges and became humulus, the hops, and another that thrived in open, mineral-rich soils, evolving into cannabis. This divergence occurred across the region that is now northwestern China and the southern rim of the Qinghai-Tibet Plateau, where volcanism and tectonic uplift were rewriting the planet's geography. Pollen samples preserved in Tibetan sediments show that these early forms had already stabilized their morphology, narrow leaves, fibrous stalks, and wind-driven pollination by 28 million years ago. The plateau's gradual rise exposed these plants to high-altitude radiation, fluctuating temperatures, and seasonal drought. Under these conditions, cannabis developed its defining evolutionary defense, resin-producing trichomes. Initially, these glands served a purely ecological role, sealing wounds, deterring insects, and filtering ultraviolet light. The compounds they secreted, which would later become known as cannabinoids and terpenes, were not designed for intoxication or medicine, but as molecular armor against an unforgiving sky. As the Tibetan plateau continued to lift, global air circulation shifted, redirecting the monsoon systems that sustained much of Asia. Forests retreated, grasslands spread in waves across Central Asia, and with them came a new kind of evolutionary competition. Plants that could stretch higher to capture sunlight, root deeper to chase groundwater, and complete their life cycle before frost dominated these new ecosystems. Cannabis thrived in this transitional zone, its anatomy fine-tuned to extremes. In regions of higher humidity, it evolved open, branching forms that allowed air to move freely through its canopy. In drier plains, it adopted shorter cycles, flowering rapidly before drought closed the growing window. This plasticity, its ability to change growth patterns and chemical production in response to environmental stress, became the secret of its survival. Genetic sequencing confirms that cannabis possesses an unusually dynamic genome, nearly 820 million base pairs rich in repeat sequences and duplicated genes that act as biological experiments. Each duplication provided an evolutionary testing ground, altered proteins, new terpene combinations, or subtle timing shifts in resin production without endangering the parent code. Over millennia, this trial and error system produced one of nature's most adaptable genomes, a living record of environmental negotiation written in DNA. By the early Pleistocene, around 2 million years ago, cannabis had migrated along the great Central Asian steppe belt into what are now Kazakhstan, Mongolia, and western China. Fossilized pollen across these regions tells a consistent story. Wherever glaciers withdrew, cannabis followed. Each isolated pocket of growth developed distinct environmental signatures. Northern populations evolved compact forms with thicker cuticles and higher resin content to resist frost and radiation. Southern populations, nearer to the ancient lake basins, grew taller with broader leaves, trading chemical defense for biomass. These were not yet the classifications humans would later name as indica or sativa. They were environmental dialects, natural adaptations translated through geography. As the ice ages advanced and retreated, these plant lineages spread west toward Eastern Europe and east toward what would become the Yellow River Basin. Their seeds, lightweight yet nutrient-rich, were dispersed by birds, wind, and flood cycles, ensuring their survival even as climates shifted violently. Unlike many species that perished when ice reclaimed the land, cannabis endured by reading its surroundings, sensing the cues of temperature, day length, and soil chemistry, and adjusting its metabolism accordingly. Each epoch refined it further, embedding flexibility as its prime evolutionary strategy. What makes this lineage extraordinary is not that it survived, but how it prepared unintentionally for its future partnership with another species. Every biochemical adaptation it evolved for defense, resins, terpenes, and volatile oils would later find a mirror in human biology. Long before the first tool was shaped, cannabis had already produced compounds capable of interacting with mammalian neurochemistry. When early humans eventually arrived on the open plains after the last ice age, the plant they encountered was more than a survivor of deep time. It was a chemical archivist of Earth's extremes, carrying within it the story of adaptation, endurance, and molecular symmetry. And so, when that meeting finally occurred between a species driven by curiosity and another forged by resilience, it was not coincidence. It was the convergence of two evolutionary paths written by the same laws of survival, destined to recognize each other not through dominance or domestication, but through chemistry itself. When the last glaciers began their slow retreat around 12,000 years ago, the landscapes of Central and East Asia reshaped into the first environments capable of sustaining long-term human settlement. Meltwater rivers carved new valleys, seasonal wetlands stabilized, and the shifting winds of the Asian monsoon carried warmth into regions that had been frozen for tens of millennia. Along these reborn corridors of grass and loess, both animal herds and human migrations converged, hunter-gatherers following prey, collecting edible roots, and experimenting with plants that survived where few others could. Among those plants was cannabis, already established as a post-glacial pioneer. To early humans, this plant was not sacred, and not yet intoxicating. It was practical. The stalks were strong but light, easily stripped into usable fibers. The seeds, oily and calorie-dense, provided portable nutrition. Excavations from Neolithic sites in the Yellow River Basin and Dadawan culture settlements show impressions of hemp cord pressed into pottery dated around 10,000 years before the present. These impressions are not random decorative marks. They demonstrate that early agriculturalists had already learned to process and twist the plant's fibers into rope or thread. Such sophistication implies familiarity and sustained use, proof that cannabis was among the first species consciously cultivated for material benefit rather than simple foraging. This early interaction did not occur in isolation. The Loess Plateau, stretching east from the Tibetan foothills into the North China Plain, functioned as a natural migration corridor linking Central Asian steppe cultures with early sedentary farmers. Archaeobotanical evidence indicates that cannabis grew along these silt-rich riverbanks as a native annual weed. It thrived in disturbed soils near hearths, refuse piles, and animal pens, the same habitats humans repeatedly occupied. When these early groups began to recognize that plants growing near settlements offered desirable traits, finer fiber, larger seeds, and greater yields, they selected them, whether consciously or by habit. In this subtle shift from gathering to encouraging, domestication began. By 8000 BCE, hemp had become an integrated part of early agrarian systems across northern China and western Mongolia. Communities that cultivated millet and raised pigs also harvested hemp for cordage, fishing nets, and seed oil. The plant's low maintenance and soil tolerance made it ideal for small-scale mixed farming. Unlike cereal crops, which demanded consistent care, cannabis regenerated quickly from residual seed, effectively reseeding itself in fallow plots. Its hardiness turned it into an ecological ally, a stabilizer in the fragile experiment of early agriculture. As human populations expanded outward, they carried this resilient species with them, intentionally and accidentally. Genetic analyses of modern landraces confirm that by 6000 BCE, cannabis had spread westward into Central Asia and the Caspian Basin, appearing in pollen cores from archaeological layers along the Volga and the Caucasus. The plant's genetic diversity widened as it adapted to new climates. Populations in colder regions condensed their growth cycle. Those in warmer valleys elongated their stems and broadened their leaves. The divergence that began in the Ice Age continued, accelerated by human movement and selective pressure. Throughout this formative period, there is no evidence of cannabis being used for intoxication or ritual. Its relationship with humanity remained material and nutritional. Hemp fiber provided the first long, continuous strands capable of weaving durable cloth and rope, technologies that allowed early societies to bind, transport, and store. Its seed oil served as one of the earliest non-animal fats available in temperate zones, a stable energy source that could be extracted with primitive presses or heated stones. To these early farmers, cannabis was infrastructure, an adaptable, renewable material that extended human reach without requiring fire or metallurgy. Yet, beneath its simplicity lay a latent complexity. Each time humans chose a stalk for its strength or a seed for its richness, they were shaping the plant's genome toward greater variability. In turn, the plant's chemical defenses, resins designed for sunlight and insects, were becoming concentrated in regions where stress remained high. The domesticated and the wild existed side by side, each influencing the other through pollination and environmental exchange. By the end of the Neolithic transition, cannabis existed in two archetypes: the cultivated form optimized for fiber and food, and the wild, resinous type still thriving in mountain valleys. The stage was set for their convergence, and for a new form of human curiosity to take notice. This partnership, born from utility and endurance, was the first quiet link in a chain that would eventually connect biology, culture, and consciousness. Humanity had found in cannabis not a miracle or a vice, but a companion species, one that mirrored its own adaptability and reward for persistence. What began as survival through collaboration would, in time, evolve into exploration through chemistry. Between 10 and 6,000 years ago, as the last glacial remnants receded and the Holocene stabilized, the relationship between humanity and cannabis matured into a coevolutionary rhythm. This was not yet civilization, in the monumental sense, no temples, no written records, but it was the foundation of consistency, scheduled planting, seasonal harvest, and selective preservation. The rhythm of survival was synchronizing with the rhythm of biology, and cannabis, already fluent in environmental adaptation, fit perfectly into that tempo. By this period, the climate had entered a rare equilibrium. The Holocene climatic optimum brought warmer temperatures, predictable monsoons, and longer growing seasons. In this stability, humans developed agriculture as a philosophy of control, the belief that life could be planned. Cannabis, with its short photoperiod sensitivity and versatile growth patterns, offered proof that adaptation could be directed. It became one of the first plants to demonstrate that genetic potential could be shaped by repetition, the earliest unrecorded form of breeding. Paleoethnobotanical findings from the Yellow River Valley, the Indus Plains, and the Caspian Corridor show independent cultivation zones emerging in parallel. Hemp fiber textiles appear alongside early forms of flax and jute, yet cannabis remained unique in its dual yield, both structural material and nutrient source. Its ability to support multiple functions within a single growing season made it the backbone of proto-agricultural efficiency. By alternating fiber harvest with seed collection, early farmers discovered a renewable rotation that replenished soil rather than depleting it, a property modern agronomists now recognize as allelopathic cycling, where decomposed hemp matter suppresses weeds and restores microbial health. As human populations expanded, this efficiency allowed for surplus, one of the earliest markers of social complexity. Surplus meant storage. Storage required containment. Containment demanded materials. Hemp fiber reinforced baskets, ropes, and clay jars that held the very grains defining the Neolithic economy. Thus, Without ceremony or recognition, cannabis became embedded in the infrastructure of permanence. It was not worshipped, but depended upon. At the same time, evolutionary feedback within the plant's genome continued. Populations grown for seed were selected for oil density and uniform ripening, while fiber cultivars were isolated for stem length and tensile strength. But in the harsher regions along the Pamirs, the Hindu Kush, and the lowest fringes, plants subjected to intense sunlight, thin air, and erratic rainfall began producing thicker resin sheaths. These trichomes, rich in cannabinoids and terpenes, represented a purely defensive response to environmental stress. Yet, this chemistry, engineered by evolution to shield the plant, was the first molecular bridge between species. Within the mammalian nervous system, receptors known today as CB1 and CB2 evolved millions of years before this period, regulating mood, pain, appetite, and immune balance. When the volatile compounds of burning resin entered the air of early hearths, they met a biology already equipped to receive them. It would take centuries for anyone to recognize this compatibility, but the foundation of pharmacological resonance was already written into both life forms, the plant as emitter, humanity as receptor. By 5000 BCE, pollen analysis confirms that cannabis had spread across the entire temperate belt of Eurasia, from the Pacific coast of China to the shores of the Black Sea. In each environment, it adjusted chemically to survive: higher resin content in arid steppes, reduced cannabinoid output in humid valleys. These variations were not yet intentionally managed, but human proximity ensured genetic cross-pollination. The species was learning to exist both in the wild and under cultivation, shaping a genetic continuum rather than a binary divide. In this era, the first seeds of medicinal intuition took root, not through mysticism, but through pattern recognition. Communities living at the edge of survival learned that poultices made from the plant's leaves reduced swelling, that oils pressed from its seeds soothed cracked skin and infection. These observations were empirical, built from repetition, the same process that governed tool-making and fire management. Each success reinforced a truth that would echo across millennia. Plants carried functions beyond sustenance, and cannabis in particular seemed to restore balance where other remedies failed. The story of this period, therefore, is not one of revelation, but of awareness, the dawning comprehension that adaptation could be mutual. Humanity shaped cannabis through selective habit, and cannabis, through its chemistry, began to influence humanity's perception of relief and restoration. This was not intoxication yet. It was contact, a dialogue between endurance and observation. By the end of this epoch, the partnership between plant and human had stabilized into three essential archetypes: fiber cultivars, tall and efficient; seed cultivars, compact and prolific; and wild resinous populations, chemically fortified and geographically isolated. These would form the genetic foundation from which every future expression of cannabis would emerge, industrial, medicinal, and psychoactive alike. From here, the stage was set for transformation. The same plant that once clothed and fed humanity was about to enter its next evolutionary function, expanding consciousness itself. What had begun as survival would soon become exploration, the transition from matter to mind, from necessity to experience. By the middle of the 5th millennium BCE, the partnership between humanity and cannabis had already stabilized into a system of cultivation, selection, and use, but something subtle was beginning to shift. Across the steppes of Central Asia and the highlands of Western China, the environmental conditions that once forged cannabis into a plant of survival now gave rise to its next identity. Intense solar radiation, sparse rainfall, and thin alpine air triggered an evolutionary escalation in resin production. These resins, dense with cannabinoids and volatile terpenes, served as the plant's final defense against ultraviolet damage and desiccation. But when burned in human proximity, around campfires, rituals, or funerary offerings, those same molecules crossed an invisible threshold. They began to affect perception. The first archaeological evidence of deliberate psychoactive use appears in the Pamir Mountains at the Jirzankal Cemetery, dated to approximately 2500 BCE. Wooden braziers recovered there contained stones blackened by heat and residues rich in tetrahydrocannabinol, markedly higher in concentration than those of lowland hemp. These findings, confirmed through gas chromatography mass spectrometry analysis, show that people intentionally selected potent resin-bearing plants for ceremonial burning. The context was not domestic, but spiritual, ritual spaces where the living sought to commune with the dead. The smoke, rising from heated stones, became both offering and conduit. This act, though simple in appearance, represented a profound human discovery. That chemistry could alter consciousness, that experience itself could be shifted through interaction with the environment. The steppe nomads who inhaled that vapor were not seeking intoxication for pleasure, but transcendence through empathy, the dissolution of boundary between the seen and unseen. Their understanding of the plant was not scientific, but observationally precise. They differentiated between varieties by aroma, burn quality, and the nature of the experience, the clear head of the highland resin, the calm weight of the valley herb. In doing so, they established the earliest taxonomy of effect. Contemporaneous to this, early dynastic China recorded cannabis within the mythic pharmacopoeia of the Shenong Bencao Jing, c. 2700 BCE. There, hemp, ma, was described as an agent that restores the five organs and opens the channels of the body, yet cautioned that excessive use could cause visions of ghosts. Within that phrasing lies the duality still recognized today, a substance both medicinal and visionary, therapeutic and disorienting, depending on dose and intent. The entry predates modern pharmacology by 4 millennia, yet captures the core of receptor-dependent response, therapeutic modulation at low exposure, hallucinogenic potential at excess. In Egypt, similar insights appeared through parallel empiricism. The Ebers Papyrus, circa 1550 BCE, details treatments for inflammation, pain, and menstrual discomfort using plant-based poultices whose residue analyses suggest hemp derivatives. Pollen recovered from the mummy of Ramses II confirms cannabis presence in the region, likely introduced through trade with Asia or Nubia. Here, the plant was not smoked but extracted, mixed with honey, animal fat, or oil. These were among the earliest examples of solvent-based pharmacology, leveraging lipids to draw active compounds from plant material. Farther south and east in the Indus Valley and the emerging Vedic cultures of the Indian subcontinent, cannabis took on a distinctly spiritual form. The Atharva Veda, ca. 1200 BCE, names bhang as one of the 5 sacred plants, a source of happiness, a liberator. Its preparation, a mixture of ground cannabis, milk, and spices, functioned as both ritual sacrament and medical tonic. The combination of fat and heat in its creation reflects an intuitive grasp of lipid solubility. Cannabinoids dissolve in oils, increasing potency and duration when ingested. In Ayurvedic medicine, this became the foundation for later formulations of Vijaya, used to calm pain, stimulate appetite, and aid meditation. Meanwhile, among the nomadic Scythians who roamed the Eurasian steppes, the psychoactive use of cannabis reached a form of social normalization. As described by Herodotus in the 5th century BCE, they would throw hemp seeds onto heated stones within felt tents, rejoicing in the vapor. What Herodotus recorded ethnographically, modern archaeology has confirmed chemically. Residues found in burial chambers from the Altai region match those of high-resin cannabis. The Scythians' practice was neither casual nor primitive. It represented a structured ritual of purification and remembrance. Through controlled inhalation, they induced altered states that marked transitions, birth, death, victory, mourning. Across these cultures, Chinese, Egyptian, Indian, and Scythian, a pattern emerges that transcends geography. Cannabis moved from an external material to an internal experience. What began as fiber, fuel, and food, now entered the body as vapor and elixir. It was the same chemistry, only redirected from reinforcing walls and nets to exploring perception and relief. The plant had not changed purpose. Humanity had changed question. Instead of asking, "What can this make?" they began asking, "What can this reveal?" The psychoactive discovery was not an accident of curiosity, but an inevitability of proximity. A species that learned to control fire and air would eventually inhale what it burned. What mattered was the interpretation, and in that interpretation, the foundations of pharmacology and spirituality intertwined. Cannabis became a mirror of intent, healing when guided by precision, disorienting when pursued without respect. It taught that the difference between medicine and excess lies not in chemistry, but in use. By the end of the Bronze Age, this understanding had spread across continents. Cannabis existed simultaneously as textile, tincture, incense, and instruction, a plant that crossed the boundary between the tangible and the transcendent. The discovery of its psychoactivity did not replace its practicality. It expanded it. Humanity had found not only a source of nourishment and strength, but a dialogue with its own nervous system, a conversation between biology and consciousness that had been waiting, encoded in resin, since the age of ice. By the beginning of the Bronze Age, the world had grown interconnected through necessity. Rivers and deserts that once divided people now linked them, each serving as a corridor of migration, barter, and story. The same trade routes that carried tin, copper, and grain also moved something less visible but more enduring: knowledge. In that current of exchange, cannabis became both a commodity and a language, its fibers binding the infrastructure of trade, its resin shaping the pharmacology and theology that traveled alongside it. Across the Iranian plateau, between the Zagros Mountains and the Caspian Basin, the early Persian world inherited the plant through contact with the Indus Valley and the Central Asian steppes. Archaeological digs at sites such as Tureng Tepe and Shahr-i-Sokhta have yielded hemp seeds and burnt resin fragments dated between 3000 and 2500 BCE, often found near ceremonial hearths. The Avesta, one of the oldest Zoroastrian texts, refers to bangha, likely cognate with the Sanskrit bang, as a plant that drives out death and restores awareness. Whether literal or symbolic, the context places cannabis within rituals of purification and rebirth. Its smoke accompanied the sacred fire, merging plant chemistry with theology. In Persia, psychoactivity was not vice but revelation, a means to perceive the divine order, asha, underlying existence. Further west, the great floodplains of Mesopotamia treated the same plant as medicine rather than sacrament. Cuneiform tablets from the Assyrian and Babylonian archives record an ingredient called kunabu, translated by scholars as a hemp-based resin blended with myrrh and wine for anointing the sick or fumigating temples. Chemical residue from incense burners excavated at Assur and Nineveh reveals cannabinoid traces mixed with frankincense, suggesting that therapeutic and ritual practices were inseparable. To the Mesopotamian healer, fragrance was function. What pleased the gods also cleansed the body. These records, spanning 15 centuries, stand as some of the earliest written formulas bridging plant extraction and spiritual hygiene. As trade intensified, the twin identities of cannabis, mystic and medicinal, traveled along with the caravans. Hemp cloth, seed oil, and resin cakes moved east toward the Tarim Basin and west toward the Levant, carried on the same roads that later formed the Silk Road skeleton. Traders understood that certain varieties from the mountains of Bactria or the plains of Fergana had distinct strengths or clarities. They described these differences in sensory language: heat, sharpness, smoothness, that anticipated pharmacological classification by millennia. When these goods reached markets in Sumer, the Indus, or early Egyptian outposts, they were already differentiated by quality and origin. The first rudimentary terroir had emerged. By the second millennium BCE, cannabis had crossed into Africa through two main vectors. One moved south along the Nile through Nubia, evidenced by hemp pollen found in Kerma period graves. The other followed the maritime winds of the Indian Ocean, linking Gujarat, Yemen, and the Swahili coast. Hemp cordage recovered from shipwrecks off Oman and Kenya suggests that early seafarers valued its salt resistance above all else. On land, African cultivators adapted the plant swiftly to tropical conditions. The equatorial sun intensified resin formation. Within generations, regional varieties with distinctive chemical profiles appeared, precursors to the land races that would later define the continent's pharmacology and ritual. By 1000 BCE, cannabis had become both crop and companion across East Africa, grown for rope, oil, and the calming properties of its smoke. Meanwhile, the overland networks connecting Central Asia to China matured into arteries of cultural transfer. The Hexi corridor became a living laboratory of hybridization, where Chinese hemp cultivars, bred for long, pliant fiber, intermixed with resinous mountain strains from the Pamirs. Genetic studies of preserved seeds from the Turpan Basin confirm cross-pollination between these populations, producing plants capable of thriving in both humid lowlands and high deserts. This silent fusion created the genetic groundwork for the dual-use cannabis that would dominate the next several millennia, plants yielding both industrial fiber and pharmacologically active resin. The Silk Road did more than spread the plant, it standardized it. As caravans crossed regions, traders documented sensory cues to assess quality. The sweet smoke of the east, the warming oil of the south, and the bitter seed of the north became shorthand for chemical differences born of climate and soil. Such descriptions prefigured the scientific understanding of terpene families that modern researchers categorize as limonene, caryophyllene, or pinene. The language was poetic, but the observations were empirical. The ancient merchants, without instruments, were already practicing chemistry through commerce. By the end of the first millennium BCE, cannabis encircled the Old World's trade sphere. From the Mediterranean to the Himalayas, it existed in multiple registers: a medicinal oil in Mesopotamia, a ritual incense in Persia, a fiber in China, and a spiritual elixir in India and Africa. Each culture interpreted its chemistry through its own philosophy, humoral balance, divine fire, bodily harmony, but all recognized its capacity to heal and to transport the mind. The plant had become a mirror of civilization itself, adaptive, connective, and translatable. This diffusion marked the true globalization of cannabis, not as conquest, but as communication. It taught humanity that a single organism could hold within it the logic of survival, the language of trade, and the mystery of consciousness. From this convergence would arise the next great synthesis, the systematic study of how preparation and dosage transformed utility into medicine and medicine into art. The trade routes that would one day be called the Silk Road did not emerge overnight. They grew out of repetition. Trails first cut by migrating herders hardened under the hooves of caravans, carrying with them more than metal and spice. Each journey left behind a genetic signature, seeds, spores, and grains that drifted into new soils, changing the chemistry of life along the way. Among these stowaways, cannabis proved the most fluent traveler. Its seeds endured the cold and heat, the crush of cargo, and the dryness of the steppes. By the middle of the first millennium BCE, it was no longer bound to one climate or culture. It had become a global species, shaped by both wind and intention. Across the mountain corridor stretching from the Fergana Valley through the Tarim Basin to the Loess Plateau, two distinct populations converged. To the east, Chinese cultivators had refined hemp into a model of efficiency. Tall, hollow-stemmed, with fibers so uniform that early weavers called it cloth from the wind. Its chemistry leaned toward low resin and high cellulose, perfectly suited for rope, paper, and sail. To the west, highland farmers of the Pamirs and the Bactrian plains favored shorter, denser plants, whose surfaces shimmered with resin under sunlight. Their plants smelled of pine, pepper, and spice, aromatic defenses against aridity that coincidentally carried psychoactive weight. When trade between these regions intensified, the seeds mixed in the hands of merchants, creating the first recorded hybridization between fiber and resin lineages. Archaeological evidence from Turpan and Nia in modern Xinjiang captures this transition in tangible form. Tombs dating between the 8th and 4th centuries BCE contain hemp textiles woven with fibers of mixed thickness, suggesting hybrid stocks, and jars containing residues with cannabinoid concentrations higher than those of earlier hemp varieties. Modern genomic analysis of these ancient seeds reveals dual inheritance, markers from East Asian fiber cultivars intertwined with Central Asian resin genes. This was not accidental diffusion, it was evolution under human influence, guided by selective habit rather than formal science. As these hybrids spread, ancient observers began to recognize distinctions in effect and expression. Chinese agronomists during the Zhou period described hemp that warms and hemp that clears the mind, language that differentiates psychoactivity through subjective experience. Steppe traders referred to singing hemp, a term carried through oral tradition, and later translated by Greek chroniclers as the variety used in Scythian rites. These terms mark the birth of classification, not yet chemical, but phenomenological, rooted in observation. People were beginning to catalog the plant not by shape or yield, but by sensation. The geography of this hybrid zone amplified diversity. In the cooler basins of the north, long daylight hours selected for taller phenotypes with low resin density and mild aroma. Southward, near the Oxus and the arid Iranian fringes, short seasons and punishing light forced rapid flowering and resin thickening. This contrast between endurance and defense became encoded in chemistry. Plants from higher altitudes accumulated more bicaryophyllene and humulene, grounding aromas with a calming physiological profile. Those from low, sun-drenched plains expressed brighter monoterpenes like limonene and pinene, stimulating and sharp. These compounds, which modern science knows to modulate cannabinoid activity, were already being perceived through ancient senses of smell and feeling. Trade amplified awareness. Caravans moving between Kashgar and Samarkand carried sacks of seed marked by origin. Merchants noticed that hemp from the mountains fetched higher prices, not for its fiber, but for its fragrance. Resin-rich varieties produced thicker smoke and longer-lasting effects when burned in rituals or consumed as infusions. Across generations, this preference drove unconscious selection toward potency. What began as environmental adaptation evolved into human expectation. Strength became a measurable commodity, not by laboratory scale, but by collective memory. The philosophical implications of this were not lost on early healers. Indian Ayurvedic physicians of the late Vedic and Mauryan periods began cataloging cannabis preparations under two names: Vijaya, meaning victory, used for calming and healing, and Siddhi, meaning attainment, associated with spiritual elevation. These distinctions correspond closely to modern classifications of sedative and euphoric chemotypes. At the same time, Persian herbalists, writing precursors to later Islamic medicine, noted that mountain hemp warms the head, while river hemp cools the blood. Across language barriers, the consensus was forming. Cannabis was not singular. Its potency varied by soil, altitude, and treatment, a revelation that marked the beginning of empirical pharmacognosy. Cultivation methods adapted to match this growing understanding. Chinese hemp fields, once sown densely to encourage long, fiber-dominant stems, began to include wider spacing in certain plots to allow fuller flowering tops, an early recognition that isolation increased resin yield. In the West, cultivators pruned lower branches to push energy upward, creating compact canopies rich in trichomes. These refinements foreshadowed modern horticultural practices: canopy control, photoperiod management, and phenotype selection. The logic was the same then as now: light, stress, and space-shaped chemistry. By 300 BCE, cannabis agriculture had effectively split into two traditions. One was agronomic, dedicated to structure, rope, cloth, sale. The other was alchemical, dedicated to essence, oil, incense, and medicine. Yet even as these purposes diverged, The plant remained one species, capable of reverting or hybridizing with a single exchange of seed. Its diversity became its immortality. As the Silk Road matured into a continental network, cannabis moved with caravans as both cargo and culture. It was sold by weight and by scent, valued as textile and tonic alike. Through its constant crossing of borders, humanity began to see itself reflected in its adaptability, a species defined not by uniformity but by variance. Cannabis had become a biological record of civilization's movement, a living testimony that chemistry evolves wherever curiosity travels. The next horizon would test that adaptability further. As empires consolidated power and knowledge into institutions, the plant would move from trade good to documented medicine. Its variability would no longer be described through story or scent, but measured through theory, the transition from inherited wisdom to written pharmacology, from experience to analysis. By the time the Silk Road pulsed with regular caravans, cannabis had become more than a crop. It was an archive of its environment. Each region wrote a different signature into its genome, and the plant transcribed those conditions into chemistry. No two valleys produced the same fragrance, no two harvests the same effect. Geography was no longer just the setting of cultivation, it was the author of expression. The plant's biochemical diversity was an ecological map rendered in scent, resin, and resilience. In the steppes of Central Asia, where summers blazed long and nights plunged cold, the plant learned to harden its chemistry against contrast. Extended daylight drove photosynthetic output, while nightly frost demanded rapid repair. This cycle favored dense trichome formation, microscopic resin glands rich in sesquiterpenes like B-caryophyllene and a humulene. These compounds sealed moisture, repelled insects, and gave the dried flowers a peppered, earthy aroma. The result was the archetype of mountain hemp, pungent and grounding, its smoke thicker and slower to burn. Modern chromatographic analysis of preserved Central Asian resin mirrors this ancient adaptation. Cannabinoid concentrations near 2% paired with high antioxidant terpene ratios, an evolutionary proof of chemical endurance. Further east, in the monsoon-fed river basins of China, humidity rewrote the plant's priorities. Constant moisture punished excess resin and rewarded elasticity. Here, the genetic expression leaned toward fiber, with low trichome density and long internodes that resisted mold. The volatile profile shifted to lighter monoterpenes, myrcene, limonene, and oxymene, producing grassy and citrus notes. These chemotypes yielded minimal intoxication, but unparalleled tensile strength, ideal for rope and cloth. The same environmental pressures that dulled psychoactivity perfected utility. West of the Pamirs, in the arid basins of Bactria and the Iranian Plateau, ultraviolet radiation carved potency into survival. Under relentless light and limited water, the plant upregulated enzymes converting cannabigerolic acid into THCA and CBDA, fortifying its resin against desiccation. The brighter the sun, the richer the psychoactive shield. Archaeological residues from the region's incense burners show these populations carried elevated THC content compared to their eastern relatives, confirming that sunlight itself acted as a molecular breeder. Traders who crossed these highlands spoke of warming hemp, a smoke that quickened thought and dulled pain, an early empirical recognition of cannabinoid response. Southward, along the Indus and through Bengal's coastal plains, the challenge reversed: fungus and monsoon rot. In these conditions, cannabis produced defensive volatiles, borneol, camphene, and eucalyptol, strongly antimicrobial and aromatically sharp. Preparations from this belt were labeled ushna, warming, by Ayurvedic physicians, prescribed to open the chest and clear the lungs in damp climates. The environment had created not just a plant, but a pharmacological dialect. Chemistry adapted to culture because it first adapted to weather. Even the Mediterranean fringe left its mark. Where calcium-rich soils met long, dry summers, plants expressed linalool and terpinolene, floral terpenes that softened the harsher sesquiterpene base. Greek and Carthaginian farmers favored these for linen blends and fragrant oils, unknowingly selecting for terpene profiles that modern researchers associate with mood elevation and relaxation. What was commerce for them was biochemistry in action. The same pathways that strengthened cloth also perfumed the air and tempered the mind. Across these zones, humans began to recognize a pattern that soil, light, and altitude dictated behavior. They lacked the vocabulary of enzymes and alleles, but possessed the sharper language of observation. Steppe traders spoke of hot and cold smokes, Chinese agronomists of male and female hemp, Indian healers of Vijaya and Manda, the stimulating and the calming. These were the first taxonomies of effect, sensory systems that predated scientific classification by millennia, yet reached similar conclusions. Every culture learned to read chemistry through experience, and every environment became a laboratory. What tied all of this together was the logic of feedback. Each harvest reshaped the next generation's genetics. Seeds saved from high-resin mountain plants produced offspring adapted to thin air. Seeds from river valleys yielded long fiber and low scent. Human selection intersected with climate selection, creating a constant loop of adaptation. This is why modern genomic surveys still reveal localized terpene clusters that match ancient trade maps, proof that chemistry remembers where it was born. By the close of the classical horizon, these regional chemotypes had become cultural signatures. Resin from the Iranian plateau was prized for clarity, northern hemp for strength, Indian bhang for warmth. Each identity reflected a relationship between stress and solution, environment and expression. The planet itself had written the formula. From this chemical geography emerged the foundation of pharmacological curiosity. When healers and philosophers began to compare notes across ports, temples, and caravans, they discovered that the plant did not change randomly. It responded. Altitude, humidity, soil, pH, harvest time, all variables that modern laboratories quantify, were once felt through scent and smoke. The understanding that environment sculpted essence was the birth of classification, the first step from observation to analysis. The world had not yet entered the age of empire, but cannabis already spoke in dialects of chemistry, each fluent in the conditions that made it. The next stage would see those dialects codified in Greek medicine, Chinese agronomy, Indian ritual, and African pharmacology, as the plant transitioned from living archive to documented science. When empire emerged, it did not invent knowledge, it organized it. The scattered traditions of cultivation, medicine, and ritual that surrounded cannabis were drawn into bureaucratic order. What had once been passed by story and apprenticeship was now codified in ledgers, pharmacopoeias, and agricultural decrees. Hemp and cannabis entered the administrative consciousness of civilization, as material, as medicine, and as metaphor. The plant's chemistry, shaped by geography, began to be interpreted through philosophy and governance. In Greece, where observation was elevated to discipline, the study of plants became an ethical act, the pursuit of order in nature. Physicians under the Hippocratic school cataloged the effects of cannabis within their doctrine of humors. Its seeds were recognized as cooling and desiccating, counterbalancing heat and inflammation. The expressed oil softened tissues and eased pain. The logic was not spiritual but systemic. If excess heat caused disorder, a drying agent restored equilibrium. This correlation reflects a remarkably accurate empirical intuition about cannabinoid modulation of inflammation. By the 4th century BCE, references to cannabis appear in Theophrastus's Inquiry into Plants, the earliest surviving botanical treatise, describing its use for rope and for relief of pain when prepared. Here, utility and remedy shared a page, industry and medicine treated as expressions of the same natural principle. The Romans inherited this duality and made it infrastructure. Hemp cultivation was written into law as a strategic resource. Pliny the Elder, in his Natural History, 7 CE, described the plant as indispensable to naval power, no cordage more useful to sailors. Roman engineers standardized its cultivation across the empire's breadth, from Egypt to Britannia, ensuring the fleet sails and ropes could be replaced in any port. But hemp was not only a military asset. Roman physicians, notably Dioscorides, expanded the Greek medical record by differentiating between preparation methods: boiled seed for cramps, roasted seed for dryness, poultices of leaves for inflammation. The intent was precision, recognizing that preparation altered function. That framework, though couched in humoral terms, constitutes one of the earliest written systems of pharmacokinetic reasoning. While Mediterranean empires were weaving cannabis into their material and medical economies, the Chinese were refining it into administrative science. Under the Han Dynasty, 206 BCE, 220 CE, the imperial agronomist Fan Shengzi classified hemp among the Wugu, the 5 foundational grains of state agriculture. The listing was not metaphorical. Hemp seed provided oil and protein, its stalk essential fiber for uniforms, bowstrings, and paper. Archaeological finds at Mawangdui include government-issued hemp cloth with uniform thread counts, proof that cultivation and textile production were centrally regulated. In parallel, Han medical compendia preserved a sophisticated pharmacological language around Emma, distinguishing between male and female plants, seed and flower, warm and neutral energies. The physician Huatuo, active in the 2nd century CE, famously used powdered cannabis mixed with wine to perform surgical anesthesia, the first recorded systemic application of cannabinoids for pain suppression. This was chemistry by empiricism. Solubility in alcohol enhanced absorption, a fact confirmed by modern pharmacology. Paper, too, was born of hemp. The earliest known sheets, from the 2nd century BCE, consist of pounded hemp fiber blended with rags and bark, a medium that allowed the empire's agricultural, medical, and bureaucratic knowledge to multiply. Hemp did not just fuel civilization, it recorded it. The plant that once followed humanity as a wild companion had now become the substrate of its memory. Southward, across the deserts and cataracts of Africa, cannabis followed both trade and theology. Egyptian papyri of the New Kingdom, circa 1500 BCE, reference plant infusions for ocular inflammation and uterine pain, whose residue analyses show cannabinoids. The continuity of that medical logic persisted into the Kushite and Meroitic kingdoms, where resin and oil were blended with unguents for preservation and healing alike. Among Nubian embalmers, the same chemistry that resisted decay in living tissue was enlisted to preserve the dead, a symbolic recognition of the plant's power over transition. By the 1st millennium BCE, Phoenician sailors had introduced hemp cultivation along North Africa's Mediterranean coast, merging it with local linen traditions. The plant's durability and fragrance made it both cloth and commodity, spreading from Carthage into sub-Saharan trade routes. In these African contexts, cannabis was never divorced from philosophy. Its smoke was understood as a vessel of vital spirit, capable of mediating between flesh and ancestor. The act of inhalation mirrored prayer, breath as communion, exhalation as offering. Such interpretations did not contradict medicine, they completed it. Healing was understood not just as the mending of tissue, but as the alignment of vitality, an understanding that parallels the psychophysiological balance modern researchers call homeostasis. As empire linked distant worlds through trade and conquest, the plant's dialects of chemistry became dialects of meaning. Chinese scholars recorded its neutral nature, Greek physicians its cooling temperament, Indian healers its dual capacity to soothe and awaken, African mystics its spiritual equilibrium. Each system, though framed by its cosmology, converged on the same core realization. Cannabis was not a fixed entity. Its character shifted with environment, preparation, and intent, a dynamic equilibrium between substance and context. The Silk Road served as the connective tissue between these understandings. Caravans carried hemp cloth from Chang'an to Antioch, Roman glass to Xi'an, and knowledge to every oasis between. Buddhist monks crossing Central Asia transmitted Chinese herbals that described Emma as harmonizing the five organs. Persian translators rendered those texts into Arabic centuries later, preserving them through the Abbasid Golden Age. Greek physicians stationed in Alexandria encountered Indian bhang and adapted it into Mediterranean pharmacology. This was not cultural diffusion, it was intellectual hybridization, the same process that once merged mountain resin and river fiber. By the close of antiquity, cannabis had become a global constant, a material that bound sales and nations, a medicine that crossed languages, and a philosophical mirror reflecting the balance between use and excess. It was present in every empire, yet belonged to none. To the statesman, it symbolized order. To the healer, balance. To the mystic, insight. The next step in its evolution would be the refinement of those understandings into method, the art of extraction, preservation, and dosage. Ancient healers would learn to distill the plant's chemistry into oils, wines, and salves that extended its life beyond harvest. The story of cannabis was about to shift from the fields to the laboratory of antiquity, where observation met transformation, and chemistry began to take deliberate form. In the empires of antiquity, medicine was not the isolated practice of a few specialists, it was the intellectual scaffolding of civilization. To heal was to understand balance, and to understand balance was to decipher the invisible laws that governed life itself. Every culture framed those laws differently, but all converged on the same premise. Health was harmony, and matter could either restore or disrupt it. Within that framework, cannabis became a paradoxical teacher, a plant whose potency depended on method, whose nature changed with handling, and whose dualities forced early healers to think like chemists long before chemistry had a name. In Greece, this reasoning found order through the doctrine of the four humors: blood, phlegm, yellow bile, and black bile. Disease was seen as an imbalance among these fluids, and medicine, therefore, was the art of counteraction. Cannabis, Cannabis emeron, was classified as cooling and drying, a subtle but precise diagnostic label. Crushed seed mixed with oil soothed inflamed joints. Decoctions of the same seed, boiled and filtered, were prescribed for cramps and edema. Each preparation altered the plant's temperament. Oil extracted its moist essence, while boiling tempered its dryness. Hippocratic physicians did not know of terpenes or lipids, yet their empirical understanding mirrored the modern concept of solubility and delivery medium. They understood that a substance could behave differently depending on how its properties were released, a truth that would remain fundamental to pharmacology. By the Roman period, medical empiricism had matured into standardization. Dioscorides, writing in the 1st century CE, recorded in De Materia Medica that the juice of the green seed alleviates pain when applied, yet used in excess dulls the senses. The phrase is the first written acknowledgement of dose-dependent response. Roman apothecaries, operating under Galenic influence, blended cannabis with honey, vinegar, and wine to produce variable effects, observing that the same plant could sedate or stimulate depending on proportion and vehicle. They had entered the era of controlled formulation. The guiding principle was ratio, the measurement of relationship, not simply quantity. To the Romans, healing was mathematics in motion. In China, pharmacology advanced through analogy. The medical classics of the Han and Tang dynasties classified substances not only by physical property, but by their energetic temperature and directional influence within the body. Cannabis, Ma, was considered neutral in temperature, moving both upward and inward, harmonizing extremes. Its seed, being oily and heavy, nourished yin. Its flower, light and aromatic, moved qi and cleared blockages. Practitioners noticed that aging dried flowers intensified their mind-altering potential, while freshly harvested material remained gentle. This was the earliest recognition of decarboxylation, the chemical process by which heat or time transforms inactive acids into active cannabinoids. Without understanding molecules, they perceived transformation through observation. The same herb, differently treated, changed its influence on the human spirit. The Indian subcontinent, inheriting Vedic ritual and developing Ayurveda's Tridosha system, approached potency through relational philosophy. Cannabis occupied no fixed place in this cosmology. It moved according to use. As Vijaya, it was medicine, clarified in ghee or milk to soothe vata, the dosha of motion and nerve. As Siddhi, it was spiritual catalyst, consumed in rituals to elevate perception and dissolve ego. Both were bound by the same rule, matra, or correct measure. The texts warned that too much heat, pitta, or stagnation, a kakapha, could distort the experience, turning medicine into poison. Ayurveda's concept of gunas, the intrinsic qualities of lightness, sharpness, and subtlety, mapped uncannily onto what modern pharmacology describes as onset speed, penetration, and diffusion. Ancient healers read bioavailability through texture and sensation. In Egypt and along the African Nile, medicine fused with ritual, but was no less analytical. The Ebers Papyrus and later Coptic texts describe infusions of hemp with honey or castor oil for inflammation, respiratory relief, and uterine pain. The preparation involved heating until fragrance rose, a sensory cue for activation. Here again, observation anticipated chemistry. The moment of vapor release marked the conversion of raw matter into essence. Egyptian healers distinguished between topical and ingestible potency, understanding that the body absorbed through skin and stomach at different tempos. They measured time, not weight, as their pharmacological unit, a concept parallel to pharmacokinetics. Across continents, the same conclusions emerged from different languages. Potency was not inherent, it was conditional. The effectiveness of any medicine depended on context, heat, medium, timing, and the temperament of the patient. The healer's role was to interpret those variables and craft harmony out of volatility. Cannabis, by its nature, forced this awareness. Its effects were neither constant nor binary. A single change in preparation, a longer soak, an aged flower, an added fat, could redefine its purpose. In this way, the plant became both subject and teacher of pharmacological method. What united these ancient systems was their faith in correspondence, the belief that the microcosm of the body reflected the macrocosm of nature. Solubility, volatility, and dosage were not mechanical processes, but metaphors for cosmic balance. The Greeks expressed it as the equilibrium of humors, the Chinese as the alignment of yin and yang, the Indians as harmony among the doshas, and the Africans as the tuning of spirit. All were correct within their frameworks, and remarkably consistent with what modern pharmacology would later quantify as homeostasis. By the close of the classical world, cannabis had evolved from a trade good to a controlled substance of study. The healer's mortar and pestle became the first laboratory, the temple and infirmary, the first classrooms of chemistry. They had learned that potency could be summoned, subdued, or suspended. Through that understanding, medicine ceased to be reactive and became intentional. Humanity had discovered not just how to use the plant, but how to translate it, a living equation between matter, method, and meaning. What began as a story buried in the soil has now unfolded through time, a conversation between life, light, and language itself. We've watched this plant evolve from survival to significance, from an ancient tool to the root of medicine and meaning. It's strange when you think about it, how something that's been with us for millions of years can still feel misunderstood today. But maybe that's the point. Every generation rediscovers what the last one forgot. Cannabis isn't new, it's memory resurfacing. A reminder that the chemistry of the earth and the chemistry of the body were never separate. If you've been watching this series, I hope you take away more than dates and facts. This isn't just history, it's continuity. Every fiber, every seed, every spark of curiosity we've uncovered connects back to us, to our biology, and to our imagination. The story doesn't end here. This was only the first chapter, the deep roots of the relationship between humans and cannabis. From here, we'll move forward into alchemy, trade, colonization, and rediscovery, the centuries where knowledge was buried, outlawed, and then reborn. So, thank you for being here, for watching, and for learning with me. If this connected with you, share it. Not for clicks, but for clarity. The more we understand where this plant came from, the better we can understand where it's going and where we're going with it. This content is for educational and informational purposes only. It does not promote or encourage the use, sale, or cultivation of cannabis where prohibited by law. Always follow your local, state, and tribal regulations and consume responsibly where legal to do so. All narration and sound design are original. No third-party music or licensed tracks are used.